Houston, can you hear me? Today, I want to tackle the rest of replacing the caps on this thing. Alright, let's get those two on there. We'll double check. That's 150, that's a 150. And then on the, yep, okay, cool. I've gone ahead and splayed the legs out a little bit so that we can kind of hold it in place. Ow, burn myself. Is it really soldering if you don't burn yourself once in a while? Here we go, 3316 volt. So this one goes right in here. And then the other one, 3316, is at the top right. Go ahead and flip this board over and kiss these with a little solder. Just make sure that all these are well soldered. I think they are. I think we're good. Now to deal with the massive buttload of flux that's on the board. I think this may have been wave soldered. I don't know. That might be why there's like a ton of flux on it or something. But oh yeah, that's definitely like original flux. I just ended up cleaning a bunch off. Yeah, so I've cleaned it up enough. We'll let it dry for a little bit. I gotta clean my fingers off. Jeez. Hey, Love Rar. So you're trying to mess with the breadboard. There's a whole row of lights down at the bottom left that you can mess with. You just got to connect them to ground and to the top rail. I wonder if this thing is dry enough to test. I bet you it is. It's probably fine. I'm trying to collect all these before they end up in your feet. They call them legs because that's where they're going to stab you. We'll reassemble it to the point to where we can plug it in and see if it works. Oh my god, it got flux everywhere. Oh my god, these clips are awful. It's not the clips that are bad, it's the sleeve on it. The sleeve on it is so slick. Okay, so that should be 6 volts. Let's see if it fires up or catches fire. Nada. A whole lot of nothing. Okay. So it's still not working. Whatever shall the problem be? Start probing it again, I guess. Oh, what? Now it's pulling something? 0.39 amps? Nothing? I'm confused. I don't know. Oh, where's that schematic that I had? The block diagram or whatever, pinout. That's interesting. So we've got segment driver sections right here. H, G, F, E, D, C, B, and A. And on the board, I've got some similar markings right here. We've got P, G, F, E, D, C, B, A, H. So maybe we can check the segment drivers for voltage and see what those are getting. So how the fuck do we do that? I don't know what those are supposed to be voltage-wise. So I'm only getting a couple volts, like 0.02 volts out of some of the segment drivers. Is this fuse bad? No. Because if the fuse is bad, then I wouldn't be getting anything on the board. Also, it looks fine. Okay, so what else could be wrong with it? VDD is supposed to be negative voltage. That's pin 14. That's this one right here, I believe. Let's check that. Yep, 5.8. And then opposite of that is VGG. That's also negative voltage. Okay, common voltage is right up here, 6 volts. So we're getting 6 volts to the chip. Let's try segment driver H, pin 23. We've got 6 volts going out to that. Let's check the clock input. It's going to be this top left pin right here. Maybe there's something wrong with the actual segment board. Because it looks like it's on, right? I mean, these all look particularly fine. What do these VFDs actually take to operate? I'm guessing it's less than 6 volts, or 6 volts, right? Because we could try to power them individually, just to test and see if they work, like through the board. I have no idea how they work. But I guess that's the start to fixing or testing anything, right? Is not knowing how it works. Wise words of Jake the dog.
Dude, sucking at something is the first step towards being sort of good at something.
What is this thing? I feel like this is like the transformer for it, right? This right here is CT850. Yo, what up, Purple Really? You can control the breadboard. I was setting up some pins on the breadboard through some chat commands. Yeah, I'm not sure what this part is, but I think it is. I think it's the transformer for the low VFDs. Yeah, the thing in the top left corner. Here, let me put the camera on it for you. Discrete transistors are used to drive the display. The switching power supply located on the main electronics board is rather complex. Alright, so let's learn a little bit about these VFDs, and then maybe figure out what voltage they're supposed to be, and then we can probe the board for that voltage. Typical voltage of such a small display is only 25 volts. The larger ones need about 30 to 35 volts at a current of 3.85 milliamps. That's not specifically the same VFDs that I'm working with. You want to buy electronics, but your only source is Temu? I don't know. I can't really say because I haven't really used Temu a lot, but some people have good luck with it, some people don't. I think it's just iffy. I would say that something's better than nothing. Negative right there, and positive right here, and then we'll try probing this. I mean, if they work, they work. You might be getting knockoffs. I've heard that happens sometimes with like integrated circuits and chips and stuff, is that you get knockoffs. But if you're just testing around and like playing around and having fun, knockoffs aren't too big of a deal unless they cause confusion and issues. If you have issues with them, then that's problematic. But if they're just knockoffs, but they function the same, then I wouldn't be too worried about it. Yeah, none of these are going straight to ground. And these are powered from these two pins? Like, what is that? There's a resistor right there. And then what does that go to? That goes to a transistor right there. Yep. I'm not certain. I could probably, like, take some photos of it. Both sides of the board. And then try to sketch it up in KiCad or something. Not necessarily building. I'm trying to fix this thing. It's an old vintage calculator from like the 70s. And it's got some vacuum fluorescent displays, which are pretty cool. So I want to get those working. Yeah, so it's pretty neat. It'd be cool to get it working, but if not, whatever. It wasn't super expensive, and it's got some cool parts in here. Let's see, it kind of goes like this. Yeah, so it'd be neat to get it working. Alright, how about if I do, let's clear this, a bunch of zeros. If that does anything to help us. Does this show up as more or less lit? Got 5 volts there. 5 volts there. And this is the connector that goes to the actual like VFD board. So it makes me wonder if the VFDs are even working. Because we're getting 5 volts to them. I don't know if that's supposed to be higher or not though. Imagine it's supposed to be higher. Yeah, I've got voltages coming out of it now, so I do not know what the deal is. Oh yeah, that's a fun idea, like turning normal electronics into IoT stuff. I've seen a couple write-ups of people doing that online, and it's always pretty fun. 1, 2, 3, 4, 5, 6. This one right here, and we'll test it with the back side of this. Or we can test it. It's supposed to come over here to H. 1, 2, 3, 4, 5, 6. I guess not. My assumption could be completely wrong. Now let's see where that runs. This goes to this transistor right here. Bridge is right here with this resistor. Yeah, so every third pin is a connection with this right here. So I think that's our ground. That's the one on 1, 2, 3, 4, 5, 6, 7. It's the 7th pin in from over here. So 1, 2, 3, 4, 5, 6, 7. This dude right here. These. Is there a ground connection up here or something? Nope. Yeah, so it's definitely that pin. This one right here. I don't know where this goes, or it's supposed to go. I guess it goes to this transistor right here. This is kind of like a whole row of them. They're all connected. Their center pins are all connected. Is that the collector pin? I don't know. Not too familiar. And I'm not too sure where to go from here. I was probing around, and I'm getting 6 volts across most of the board, so I think it's working generally. I just don't know why the signal or why the voltage isn't making it to the actual VFD board. Alright, just to double check, we've got our voltage pin right here. Let's check that. Oh, not continuity. Alright, so we've got 6 volts going to the chip. Well, roughly 6 volts. So let's check one of these going out to one of the segment drivers. So 16, which is this one. This is segment driver A, which goes to, I think we've got A right over here. They've got some silk screening. I say silk screening, but it's solder screening. Let's check this going to here. No. Yeah, I'm not too sure. Yeah, I might throw this into KiCad. Like, take some photos of it and try to get the schematic down in KiCad and try to figure out where this is failing. Because right now, everything on the board looks good. I don't know enough about this chip, though. I know what it's supposed to be doing. And I feel like I should be getting more than 6 volts coming out of this dude. I feel like I should get more than 6 volts out of this dude. I think this is the transformer that's supposed to drive the voltage high for the VFDs to run. But I'm not getting what I would think I should get out of that. But I also don't know the pin layout of it either. VF2YLPRD. Maybe that's what it is. I'll look that up. Nothing. YLPRD. YLPRD. Did that come up with anything? Nope. It thinks I misspelled Lord. Good Lord. Let's find out more about these tubes and see what voltage they're supposed to be ran at. Or we can try to take them out of their little enclosure. Or maybe I can test them individually. I could try that. If I figure out what the pinout is on them, I can try testing them individually and see if they work. Maybe they're just bad. I don't know. I think this is where I saw it. Yeah. So we've got these first generation VFD tubes with 8 segment digits. Typically each digit is made of 7 anodes arranged in the typical 7 segment pattern so that all numbers 0 through 9 can be generated. Some early VFD displays have 8 segment digits as shown below. An extra mini segment giving a better looking 4. Do I have those? I don't think I have those. Oh, I do. Okay. See over to the right of the VFD. Oh, my broken ass spudger. To the right of the VFD, there's like this little notch that's coming off the 7 segment. That's what it's talking about. So we have 8 segments on this thing, which I think, given the number of pins over here, we've got 4 pins right here, 4 pins on the other side, and then a whole 2 back here. So I think these first 4 might be the actual sharp digitrons. Hey, what's up, Tibet? Between the anode and the cathode is an open grid. Applying a negative voltage to the grid switches the digit off completely. Part of me wonders if the chip is bad. The actual IC. I do kind of want to try and drive one of these. I don't know what the voltage is, though. I'm doing pretty good. Trying to fix a vintage calculator with some vacuum fluorescent display tubes. Because it's cool. And I want it to work. I mean, look at the design of this thing. Isn't that wild? Yeah, so this is kind of what I'm working with. This is the chip on the inside. And I've tested all of the pins, I guess? The segment drivers, at least. I've tested those. And I've tested the common voltage, the key matrix input, clock input. Actually, I haven't tested the clock input. That one was probably important, right? What is the clock signal? What's generating the clock signal on this thing? Is it this giant array of transistors? Or no? That's gonna be this one up here. And I believe it's coming out over to here. Might be better to get the scope on it. If it's a clock signal, I want to see it fluctuate. So maybe I'll try that. Let's see if we can get the clock signal on this thing. Let's see if we can find it. It is going to be negative right here. And the positive over here. I think it should be giving me something. Oh, is it because it's not turned on? Good doy. That might be it. Alright, so this should be a clock signal. Oh man, I'm such a fucking idiot. It's because the damn thing isn't on. Oh my god. Bruh. Okay, let's see if we can actually get a clock signal or something. I think this one should be it. No? Is it this one? Alright, that's our voltage pin, and this is our clock pin, this one. I'm not getting anything from the clock pin. Where was the 6 volts that I was seeing earlier? I could have swore with the multimeter. Unless I had that on the wrong setting too, right? Yeah, so 6 volts right there. Is the calculator important? No, it's not. It's just cool. Is it not on now? Pretty sure that's off. So getting 6 volts there. Oh, 7 volts there. So wait, is the power switch backwards? I bet we have a clock signal now. Let me check, what is it, this one? That should be our... Oops. I'm getting anything from the purported clock pin, or the CK clock input. I mean, I'm getting 7 volts. You would think. So you'd think that this CK would kind of be like going back and forth, right? The clock input. But it's just kind of there at 7 volts. That's this dude right here. I'm not sure where on this board the clock signal is actually being generated either. Yeah, the old handheld football games. Those things are fun. Wow, okay, so I did have the switch backwards in my mind. Bring it into the off, that's the off position, but this is actually the on position. Maybe what we can do is we can try, I don't want to blow the VFDs up though. Maybe we can try running them, or driving them ourselves. I don't know what voltage they're supposed to run at though. This is what we've got, these little dudes right here. It'd be nice if I knew exactly what model it was, but it doesn't tell me like a model number. Let's see what the power connectors button is. Right now it's on. Okay, so it looks like it's these bottom leftmost pins. These two right here. I guess we could bridge these two pins, and that would power into the board, or at least turn it on. Let's get a clip for that. Get our two Yumper connectors, and go grabby grabby. Right there, and right there. Alright. Pulling 0.039 amps. Take that off. Yay! Okay, so that is functioning as a power connector. I still don't know what the voltage required to run those tubes is supposed to be. Typical voltage of such a small display is only 25 volts. Oh yeah, if we're getting 7, that is definitely not enough. So maybe I could try driving it at 25 volts at a current of 3.85 milliamps. Is that enough to run some voltage through it and maybe pop one of the VFDs? So these center pins on each of the digits, each of the tubes is like about 7 volts. Yeah, that's what I was thinking. It's probably like the transformer that's gone bad on it or something. Because we should be seeing much higher voltages on the board over here. I might just use these, flip onto them. But there's kind of like a grid layout, or at least a circle of pins. And then there's like a little center pin right here, or center connection. So I think each of these corresponds to a segment, and then one of these is a ground pin somewhere. If the problem is that the VFDs aren't getting driven high enough, they're not getting enough voltage, then I probably need to replace the voltage driver, which I think is this dude right here. It's kind of transformer shaped, right? Let's try to find I guess a common ground. So there was this pin that I tested earlier. This one is, seems to be going off on like the top right pin of each tube. So that one, this one right here, and that corresponds with this pin right here, which goes to, where does that go? I have no idea. Oh, that's right. Okay, that's going down to this capacitor. I think this is a capacitor right here, ceramic capacitor. So I'm just grabbing that that pin at the top right of the VFD. That's beeping right there, which I believe comes down to right here. This whole capacitor, whatever this thing is. I don't know what that is. Maybe if I knew what this part was, I could probably troubleshoot this a little bit further than that. This is the driver matrix, though. That's kind of this whole section over here. These are all the segment drivers. This one's common with the rest of them, so I think that's like a common negative connection or something. Or is this what it is? It's saying between the anode and the cathode is an open grid. Applying a negative voltage to the grid switches the digit off completely. Or maybe that's what that is. Typically, each digit is made of 7 anodes arranged in the typical 7-segment pattern so that all numbers 0 through 9 can be generated. Some early VFD displays have 8-segment digits, an extra mini segment to give a better looking 4. So that would be 8 anodes, right? And then on the back of our thing, we've got 1, 2, 3, 4. I don't know. It'd be easier if I could see all the way in there to see all the pins. Because there's also the dot? No, that's still only 9. Because we have 7 for the 7-segment display, 8 for the little tick mark for the better 4, and then 9 for the dot. That's only 9 anodes. We have 5 right here. The markings on this has like an E and H next to it, so maybe that's like the E and H driver. So like over here, we have E, we have H. Save me, Instructables. Oh, here we go. Background in theory, fundamental VFD operating principles. We have cathode filaments, control grids, and illumination anodes. In a static display, each anode segment is individually connected to a lead pin, and a single grid covers all the display patterns in the VFD. This has the advantage that it only requires 10 to 15 volts DC to illuminate the display, and in some cases, illumination is possible using standard 12-volt CMOS logic. Is the major disadvantage is the need for more lead pins? and IC drivers as the number of anode segments increases. So multiplex drive, let's see, each character has its own separate grid, which not only diffuses electrons from the filaments, but also controls the selection of the character position in a timeshare multiplexing cycle. The duty cycle on time of each character will determine the appropriate operating voltage required to provide sufficient luminance. Eesh. Yeah, so segment driver H corresponds to like this little side piece right here. I guess it helps if I make it, yeah. So this is describing the different drive modes of VFDs. I don't think ours is taking 10 to 15 volts. Probably taking more. I think the transformer is just not doing what it's supposed to be doing. And I think that our integrated circuit is doing multiplex drive based on the number of pins that we don't have. So we're only driving it with all these segment drivers, which is definitely not enough pins for eight tubes. If there's supposed to be a common lead for each anode, I guess. I'm still not sure what the pinout for these is supposed to be. We can try to figure out where the rest of these pins go. So we've got that one is, and this runs to this little thing, this green bar looking thing. And I think that's a capacitor. Ooh, there's a part number. Holy crap. Okay, I'm gonna look it up. Oh, is it a resistor? Oh, it looks like it's a bridge or bus resistor or something. Because it has, on the side, it's got printed, hold on. Oh, NTK 100K and then ohms. So it's a resistor. NTK 100K. Wait, is that what I said? Or did I say something else? NTK 100K ohms. Bro, why is it giving me a bunch of freaking image searches now? What's wrong with you? Google! No, it's not a thermistor. I mean, it could be a thermistor, but I don't think it is. NTC, oh my god, search is fucking awful, dude. Google search is awful, you suck. Like, I didn't say NTC, I said NTK. What is wrong with you? What is there such thing as a bus resistor? What is this thing? Common pin on one side broken out through individual resistors to individual pins. Yeah, so why is it so fucking hard to search for a bus resistor like this on Google? I guess nobody would ever search that, right? NTK 220K ohm. Okay, so which side is the common, or which side is the ground on the resistor? I guess it's not ground, but common. Bus terminating resistor? What is this? Is this what I'm... No. Free! Resistor network? Oh my god. Y'all, it's called a resistor network. This thing... These things, they're called resistor networks. Now you can actually get accurate results from your web searches. It's beautiful. Look at it. Okay, so how do they work? No, I don't want to buy them. Alright, well, I guess I'll just look at the board. I'll look at the board and figure out which one is which. But I guess that answers my question of what the hell those things are. They're not capacitors, they're resistor networks. Wow. We're learning. Well, I am. Some of y'all may have known those already. Oh, it looks like it's this middle pin. Yeah, it looks like the middle pin. So this whole row of pins right here is this resistor network. Right here, this one. And you can see all these are going to like their own little place over here and over here, but this is the only one that kind of comes out and goes elsewhere. So this is going to be our common, I believe. We confirm that with this other one, this other resistor network, which is right here. This one's kind of the same. And then this is the output, or I guess input, I don't know, whichever way you want to see it. So I think that's how this works. We have our resistor network right here, and then we have a common coming out, going elsewhere. And this shit all goes somewhere else. So this is all going to like this, underneath this chip. Where it's going underneath the chip, I have no idea. Okay, answers that question. So now so this is a 100 kilo ohm resistor network, that's a 220. Which one is this? That's also a 220. I have no idea what this one is. Comes down over here, right here. into this thing. Oh my gosh. It's a good thing this is only like a 2-layer board. Yeah, I think I'm going to take some photos of this and start to like piece it all together in a KiCad or something. And we'll figure out what's going on with it then. Yeah, I'm not too sure what these are. I think I want to do a little bit more research and try to figure out what the pins are on these before I start trying to throw voltage at them. Because I'm pretty sure that's a great way to burn something out. But yeah. I don't know, I think I made some good progress. Thanks for hanging out. Bye!